Fresh water is an essential resource for life on Earth. However, the availability of water resources is becoming inadequate around the world. There is an urgent need to integrate every possible water resource to assure future water security. A potential source for reuse is recycled wastewater. At the Oroville Center for Scientific Research, wastewater is treated with a technology called Vortex Dewats. The Vortex system is more efficient than conventional methods for supplying oxygen in wastewater. It uses minimal space, requires low energy input, and quickly provides oxygen saturation in the wastewater. CSR has designed more than 200 such treatment plants of various capacities in all parts of India and in several African and Asian countries. The treatment process uses natural physical principles combined with the biological activities of microorganisms which grow naturally in wastewater. The microbes and bacteria are the actual cleaners of the pollutants in the water. The system can treat domestic sewage and non-toxic effluent. It is applicable for wastewater volumes ranging from 1 to 2,000 cubic meters a day. A treatment system is installed in the Oroville residential zone, connecting 8 places with a treatment capacity of 60 cubic meters a day. It is able to recycle the wastewater of 450 habitants. It operates through a combination of 5 different devices, using gravity flow without the use of mechanical appliances, except for the vortex pumps. A yearly desludging operation is required for the optimal operation of the treatment system. The tanks are constructed using prefabricated ferrocement technology at CSR. It can also be constructed using other suitable building materials. The prefabricated modules are designed in a modular way, and the system can be enlarged when required. The treatment system treats both black and grey wastewater. The sewage is collected via a central sewage pipe and channeled to the treatment plant. Manholes are provided at required distances, connecting several sewage lines within the habitats, while also facilitating the maintenance of the sewer line. At the end of the sewer line, a screening box is installed for preventing larger-sized debris entering the treatment system. Next is a distribution box, allowing for an eventual increase in the capacity of the installed plant. In the pre-treatment phase, wastewater flows through a settler, a 2-chamber module, ensuring the separation of liquid and solids. During this phase, the reduction in pollution is 30%. In larger systems, a balancing tank is used for equalizing and regulating the sewage flow during a longer period than just the daily peak flows. This tank ensures a more efficient use of the whole treatment cycle. The first treatment phase is a device called a baffle tank reactor. The wastewater is channeled through identical chambers where the flow is directed from top to bottom through PVC pipes. The wastewater comes in contact with a sludge layer deposited at the bottom of the chambers where the natural digestion of waste pollutants takes place. During this process, the pollution is reduced by 85%. The next device is an anaerobic filter. The wastewater moves through a filter material placed in identical chambers. For this process, cinder material is used, which is a waste product from the iron industry. The irregular cinder blocks provide an ideal habitat for the proliferation of a bacteria, reducing further the wastewater pollution. At this stage, the pollution is reduced by 90% and standards for using wastewater for irrigation are achieved. Since the entire process is taking place in a closed or anaerobic environment, the smell of the wastewater is still present. To eliminate the smell, a vortex system is used. This innovative device channels the treated water through a tube by mimicking a controlled tornado effect. The vortex oxygenates up to saturation level through a looping cycle. By adding extra vortex devices, the wastewater can also be reused for toilet flushing. The pollution reduction after this stage is 95%. A storage tank is included where the treated wastewater is stored for a short period. In addition, a specially designed compost box using organic material takes care of the absorption of the entire generated methane within the system. A pressurized return line allows the connected habitats to make use of the recycled wastewater for irrigation purposes. The volume which is not used immediately is stored in several large tanks and used for irrigation in and around the center area of Oroville. The treated wastewater can also be stored in open ponds. The technology is used in urban applications for household clusters, restaurants, resorts, hospitals, municipalities, industrial, government, and educational institutions. Wastewater is one of the sources that should be treated and reused within the water cycle. Oroville is trying to achieve water security in an urban context through the integration of several water sources, called multi-sourcing, using not only wastewater, but also rainwater, stormwater, and groundwater. Such an effort could provide solutions for urban water resource management on a wider scale.